Good evening, ladies and gentlemen. This is your well-rounded math teacher, Mr. Pickar. Here we're on Unit 1, Video 4, the notes for conversions and linear equations. And we're also going to talk about solving some linear equations. Learning targets. I can use dimensional analysis, and we're going to talk about what dimensional analysis is to make conversions. And we're going to be able to write linear equations in slope-intercept form. You probably remember this from the last couple of years using it in algebra and geometry. So, let's get on with it. Conversions. So we got a bunch of different conversions here. Some with time, some with distance for the most part. We're going to use what's called dimensional analysis right here. It's a method used by scientists to convert between units of measure using fractions, equivalent fractions. So if I was comparing something, we'll say from centimeters to millimeters. Well, 1 centimeter equals 10 millimeters. So you could say 1 centimeter over 10 millimeters, or you could use the fraction 10 millimeters over 1 centimeter. They're basically the same fraction, except centimeters are in the numerator in the first one and the denominator in the second one. And you're going to see why you need to be able to switch them around. But those are equivalent fractions. 1 centimeter equals 10 millimeters. So our first conversion here. How many seconds are there in 7 hours? We're just using time. We're not using distance here. We're just using one fraction here. So we're going to go 7 hours over, let's try that again, 7 hours, just over 1, just to write it as a fraction. Now we want to convert hours right here to seconds. But first, in between hours and seconds is minutes. So we're going to convert from hours to minutes first of all. Now, we're going to multiply that by an equivalent fraction to convert from hours to minutes. Now, I can see that hours is in the numerator here, so I'm going to put hours in the denominator here so I can eventually cross cancel them. We'll put minutes in the numerator. Now the conversion is 1 hour to 60 minutes, so it'd be 60 minutes over 1 hour. Now that helps me convert from hours to minutes because when you're working with fractions, you can cross cancel like this. But anyway, now we want to convert minutes to seconds. Up here, there's 1 minute and 60 seconds. Now I have minutes in the numerator, so I have to put minutes in the denominator so I can cancel out and be left with seconds. And that's what we want. There's 60 seconds in 1 minute. So cross-canceling, now the minutes cancel out. Not necessarily the numbers, but the labels do. So our answer is going to be in seconds. Now we're going to multiply straight across. 7 times 60 times 60 over 1 times 1 times 1. So in the denominator here, we're just going to have 1. I'll pull up our little calculator here so we can figure this out. 7 times 60 divided by, but times another 60. And I'm just going to hit enter, and we get 25,200. Let's get rid of this. And it's in seconds, so it's 25,200 seconds. That's one way to do it. Now you might think, well, I'll just take hours and multiply it by 60 minutes, then 60 minutes, multiply that by 60 seconds. You get the same answer, but this is just working with one unit of measure, which is time. When you get into 2 units of measure, then it's a little bit more complex than that. So just trying to show you guys how to use this. So a little more dimensional analysis. Once again, how many yards in 198 inches? So you start out what you're given with. We're given 198 inches, and just put it over 1 to write it as a fraction. So we don't have a measure for inches and yards, so we're probably going to convert yards to feet, and then feet to inches. So those are the 2 fractions you're going to have to create. So first of all, inches and feet. I'm going to put inches down here and feet up here. And you can see there's 12 inches in a foot. So 1 foot 12 inches. Times, the inches will eventually cancel out. How many feet in a yard? Well, I'm going to put feet down here and yards up here when I'm comparing them. There's 3 feet in 1 yard. So multiplying this out, the feet cancel out now. And it's 198 times 1, so it's 198 yards divided by, well, 12 divided by 3 is 36. So our answer is 198 divided by 36. Let me see if I have that really quick here. Yeah, you end up getting 5.5. So this is 5.5 yards if you divide it out on your calculator. Okay? Okay, a little bit more complex problem here. How fast are you traveling in miles per hour if your current speed is 50 feet per, well, it'd be 1 second. So we want to get to miles per hour. Right now we're in feet per second. So that's feet, which is distance, and seconds, which is time. So you're working with 2 different things here. 50 feet per 1 second. So we got to do a couple different conversions here. First of all, I got to change feet to miles, and I got to change seconds to hours. So you got to pick one and work with that first. So in red here, we'll start converting feet to miles. Now, there's 5,280 feet in 1 mile, so that's a pretty easy conversion. So feet in the denominator and miles in the numerator. And it's 5,280 feet per 1 mile. So right there, I've converted to miles. So I got my distance. In green, we'll do the time now. So I'm not worried about the 50 feet per second anymore. Now I'm worried about the 1 second, which we got to convert to hours. First we're going to go with seconds to minutes, and then probably minutes to hours. So our first conversion is this. I have seconds. I'm going to put that in the numerator. I'm going to put hours in the denominator. Wait a minute now. Minutes, sorry. So seconds, there's 60 seconds in 1 minute. So the seconds will cancel out, cross-canceling. And then we're going to have to convert minutes to hours. So minutes is going to have to be in the numerator, hours in the denominator. There's 60 minutes in 1 hour. So multiplying the 50, the 1, the 60, and the 60. What do we got here? 180,000. And in this case, minutes cancel out. The only label I have on the top is miles. Per, looks like 1 times 5,280 times 1 times 1. That's just going to be 5,280, and it's not really hours. We have to divide this so we can get it in miles per hour. I get 34.09, so I'd probably say that's 34.1 if you round to the nearest decimal place. Miles per hour. Miles per hour. 34.1 miles per hour. So a little bit more complex problem using dimensional analysis. So, do one more for you here. A car's speedometer says you're traveling 50 kilometers per hour. How fast are you traveling in meters per second? So I want to go from 50 kilometers per hour. So that's your first fraction. 50 kilometers per 1 hour, if it's kilometers per hour. And we're going to convert that to meters per second. So you're working with distance and time. So I always do the top one first, kilometers, whatever. And it looks like there's 1,000 meters in 1 kilometer. So to convert that to meters, I'm going to put kilometers on the bottom so I can cross-cancel them. Meters on top. There's 1,000 meters in 1 kilometer. It's right there. I'm working with meters now. The key is to get hours to seconds. So we'll do that in green here. Time now. Time, hours per second. So I'm going to go hours per minute first, and then convert those minutes to seconds. So I'm going to put hours in the numerator because I have hours in the denominator here. I want them to be able to cross cancel. Minutes here, it's 1 hour, 60 minutes. That's your equivalent fraction. Times. Now, hours cancel out. Minutes will go in the numerator, and we're converting to seconds now. There's 60 seconds in 1 minute. So my minutes can now cancel out. So the two labels I'm working with are meters, that's my distance, and seconds, that's my time. Multiplying straight across on top, looks like we're going to get 50,000, 50 times 1,000, 50,000, all over, what do we got? 60 times 1 times 1, 3,600. If you divide those, it looks like you get 13.8 repeating. You could leave it like that, or you could round it to 13.9, that's fine. And I have meters per second. Meters per second. And that's a little bit of dimensional analysis. If you're still struggling with this when you're trying some problems on the worksheet, come on up, I'll work on a problem with you. We'll figure it out. Okay, some solving equations. You guys have done a lot with this. We're just going to go over a few problems. I got some simple steps here to solving equations. First one is simplify both sides. That means get rid of parentheses or combine like terms. It looks like the left side and the right side are both simplified. All variables on one side. So that means if you have an x or a variable on both sides, you're going to subtract or add to get them all on one side. There is only one x term, and that's right there. It's negative x over 2. And it says isolate the variable term. That means we got to get x by itself. Now, we're dividing by 2 and we're adding 2. Well, it's kind of order of operations backwards here. First, we want to get this whole term, negative x over 2 by itself. So we're going to subtract 2 from both sides. Negative x over 2 equals, adding these together, negative 2 minus 2, or negative 2 plus a negative 2 is a negative 4. Now, if you're dividing by something, we're dividing by 2 here. I'm going to multiply both sides by 2. That's the same as multiplying by 2 over 1, so they would cross cancel. Here, there's no fraction, so I'm just multiplying by 2. I'm left with this negative x equals negative 8. Well, this is basically negative 1x. You could put a little 1 there if you wanted to. There's no coefficient, so it's divided both sides by negative 1. X equals 8. So a little bit with solving equations. Here's another one. The first 2 steps we don't need to do. Both sides are simplified, and all variables are on one side. Here it is, n. Now, some people might think, well, I got to add 8 to both sides, but this is all one great big fraction. So in order to get to that negative 8 and n up in the numerator here, we're dividing by 3. I'd multiply both sides by 3, which is 3 over 1. So these cancel. And that would get rid of the 3 in the denominator. So I got negative 8 plus n equals negative 18. So now, to isolate, get it by itself, that n by itself, I'm going to add 8 to both sides. And n equals negative 18 plus 8 is negative 10. Good. Moving right along. Hey, if you're good with equations, you can skip right to the next section. I'm going to do these 2 other equations. But if you're good with solving equations, feel free to move ahead a little bit. Anyway, here we go. Simplify both sides. So we're going to have to do some simplifying here. Get rid of these parentheses, and then there's an x term here and here. They're both on the right-hand side, so I'm going to eventually combine those 2 terms together. But first, using the distributive property here to get rid of parentheses. 48 equals 4x minus, okay, negative 4 times 4x is negative 16x. Negative 4 times negative 3 is positive 12. Okay, what do we got here? I got an x term here and an x term here. They're on the same side, so I'm not going to add or subtract them to both sides. I'm just going to combine these terms. They're like terms. 4 and negative 16 is negative 12x plus 12. Okay. All variables on one side, we already have that. There's only one variable here, negative 12x. So isolating that variable term, we're going to subtract 12. 36 equals negative 12x. And then finally divide both sides by negative 12. And I get x equals negative 3. Good. Okay. This bad boy. Simplifying both sides again, getting rid of those parentheses. I'm going to distribute here. I'm going to get 12. 4 times 3 is 12. And then 4 times negative 5 is negative 20x equals 72. So we simplified both sides. All variables are already on one side. Now we just have to isolate the variable term. That's our last step. So to get, first of all, negative 20x by itself, I'm going to subtract 12. And negative 20x is going to equal 72 and negative 12 is positive 60. Divide both sides by negative 20. And x equals negative 3. There we go. So these are linear equations because the variable x is to the first power. So just some solving linear equations. Graphing, working with graphing a little bit here and writing linear equations. A linear function's graph is a line. Slope-intercept form is this form right here. You guys are used to it. You've seen it before. We're going to work with it a little bit again today. Y equals mx plus b. M is your slope. Okay. There's a formula for slope. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Right there. So if you have 2 points, an A point and a B point here, you're just subtracting the y values, subtracting the x values, your slope should be a fraction. And that's your movement. You're moving. Slope is always moving. If you look at this point A, we're going down and to the right. Slope is also called rise over run. So that's another way to find slope, rise over run. B is your y-intercept. Okay, that's where it crosses the y-axis. So there's my y-intercept right there. That doesn't move. It's basically your starting point. If you're graphing, you always kind of start with B, your y-intercept. So doing some work with this now. It says write an equation of a line that passes through these points. So if we look at it a little bit, just this first one here, negative 5, 3, it's right about here, 4, and then negative 6 is right about here. Here's the line. We want to find this slope, that's my M, and then we want to find this y-intercept, that's my B, and then write this linear equation in slope-intercept form, y equals mx plus b form. Well, how do we do that? Well, first we're going to find the slope, and we're going to use that formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It doesn't really matter which ones here that you make x sub 1 and y sub 1. We'll just go this is the second point and this is the first point. So y sub 2 minus y sub 1. Here's my y sub 2, negative 6. Here's my y sub 1, 3. So I'm negative 6 minus 3 all over the x's. 4, that's my y sub 2, minus negative 5. So being careful with your negatives here now. The top here, negative 6 minus 3, that's negative 9 over. Minus the negative is plus a positive, so that's going to be positive 9. So it looks like my slope is equal to negative 9 divided by 9. You can just write it as negative 1. A lot of people would say negative 1 over positive 1, but if you can reduce it down, it makes working this out a little bit easier. So we're going to use this formula right here. We're going to plug in our slope. And we're going to plug in a point for y and x to solve for b right here. Now, which point am I going to pick? I'm just going to pick the first one, negative 5 and 3. So when I say y equals mx plus b, and b is what we're looking for now, we already have m. For y right here, I'm going to plug in 3 equals m, which is negative 1, that's my slope, times x, in this case, it's negative 5, plus b. And then you just solve for b, okay? So when we do this, I got 3 equals Negative 1 times negative 5 is positive 5 plus b. Okay, solve for b. Subtracting 5 from both sides, I get b is equal to negative 2. So I can write my linear equation now. I have my slope, have my y-intercept. So going back to y equals mx plus b, we're going to leave y and x as it is and just plug in my slope and y-intercept, and that'll be my linear equation. So y equals negative 1, x, b is negative 2, so I'm just going to say minus 2. There it is. Slope-intercept form. We could graph that if we wanted to now that it's in slope-intercept form. Number 10, we're doing the same thing. We're still using this. Y equals mx plus b, slope-intercept form. You have to find the slope first. Changing y over changing x. Here's my two y values. Now you can go backwards. You can say y sub 1 minus y sub 2 if you want to. It really doesn't matter. So I'm just going to say 5 minus 1. But being I started with the 5 and went to the 1, I got to start with the 4 and go to the 12. So I'm going to say 4 minus 12. You could switch it up and say 1 minus 5 and 12 minus 4. You should still get the same thing. 5 minus 1 is 4, and 4 minus 12 is negative 8. So usually you don't keep the negative in the denominator. A positive divided by a negative is a negative, so we're just going to say negative, and then reduce the 4/8 down to 1/2. So negative 1/2 right there is my slope. Now plugging in the slope, and one of these 2 points for x and y is how you find b. So first of all, plugging in for y. I'm going to use the first point again, and this is my x, 4 is my x. A lot of people put 4 in for y first because they see it first, but 5 is your y value, equals mx, so negative 1/2 times x, which is 4, plus b. This is how we find our y-intercept. So we end up with 5 equals negative 1/2 times 4 is, you just plug it into your calculator if you can't do it in your head, negative 2 plus b. To solve for b now, so we can get that y-intercept, we add 2 to both sides, and we get b, in this case, equals 7. So there's my y-intercept. We found our slope right there to be negative 1/2. So plug it into y equals slope-intercept form, y equals mx plus b form. It's going to be y equals negative 1/2 x, and then plus a 7. There we go. So if you're given 2 points, you can find slope-intercept form. Okay, a little bit of graphing here. For each of the following, identify the slope and y-intercept and graph the line. Well, this is solve for y right here. So this is in slope-intercept form, y equals mx plus b. So there it is. My slope isn't negative 2x, it's actually just the negative 2. So m equals negative 2, and I'll say negative 2 over 1 because we're going to graph this now. So I want to write it as the slope. And there's my y-intercept. B equals 5. And when you're graphing, you always start out with your y-intercept. 2, 4, 5 is right there, and then you kick in your slope. Down 2 over positive 1. Down 2 over a positive 1. Or you can go, instead of going down 2 over 1, you can go up 2, back 1. As many times as you want. So here are my points. And there's my line. I didn't do a very good job graphing that, but that's how you use slope. Find your y-intercept, like we did, and then just start kicking in rise over run. Over here, my slope, well, mx. So m is equal to 1/3, and b is my y-intercept, whatever's left over here, your constant. That's negative 1. So here's negative 1. That's what you start out with, your y-intercept. 1/3, so up 1 over 1, 2, 3 right there. Up 1 over 1, 2, 3 right there. Or you can go backwards. Instead of up 1, go down 1, but then you have to go negative 1, 2, 3. So graphing this bad boy. Well, that's a little bit better. There it is. So a little bit work with linear equations and some conversions. Hey, what you do next is Unit 1, Practice 4. Peace out, Girl Scout.